Okay, hello everyone. My name is Max, and today I will present you integrating safety, bridging STPA and MBSA with an ontology-driven approach. So I will explain in a few slides. Sorry, what does it mean? And yes, just a small word that I'm not alone working on this. This is some kind of cooperation with Airbus Protect. And we've been working on this for the last year and a half or even 2 years now. Okay, so I know that some of you are familiar with STPA, not everyone, but I'm pretty sure no one is familiar with MBSA. So before we start, I will just give you a little bit of context on what these are. So the first thing is System-Theoretic Process Analysis. This is STPA. And this is a hazard identification technique. So when we have a system, whatever that is, like a aerospace system for an aircraft or an airport, but it can be also anything else. I will just talk a lot about aviation because this is my field, but you can apply to anything else. And this is a methodology in 4 steps. And what is different, at least in the aviation world, is that usually people are treating safety as a reliability issue, meaning that we check if a component fail, and then if this failure happens, how does it spread into the rest of the system, and what's the impact. But STPA is a bit different because we treat accident as a control problem. So it's not really the topic of this presentation. So I will go quite quickly on it. But what is important for today is really the last step, which is identify the loss scenario. So this is really the output of these methodologies that for a given system that we are studying, we will get a huge amount of scenarios. And what I want to emphasize is that these scenarios are really natural language. So basically we get this table with like hundreds and hundreds of scenarios. And just to give you one example, so if I take this loss scenarios 2.1, the system was an electrical system for some aircraft. And the scenario is saying the flight crew is providing the set battery to use action when the battery is disconnected and overheated. And the flight crew received the feedback that this battery is overheated. So this is one typical scenario that is potentially unsafe, that could lead to an accident, which is that I turn on the battery even though I know it's overrated and it's not working. And basically we get many scenarios like this. So this was quite quick, but now I need to tell you about model-based safety analysis because yeah, the presentation is really about putting these two things together, and I'm using ontologies to do this, but I will show you. First, let me explain you what is MBSA, model-based safety analysis. So it's a failure propagation models. And so it was created by Antoine Rossi in the 90s. And the idea is that we take a system and we model it in a dysfunctional way. So not in the nominal way. No, it's not how it's supposed to work, but we are trying to check what happens when it's in configuration where it doesn't work as intended. And the great thing about MBSA compared to STPA is that, as I said, STPA is natural language, but MBSA is using some object-oriented programming, and it's really formal. Like we can really basically code our system. And it's based on something that is called guarded transition systems. I will explain a bit more what is it here. Maybe it's a bit more easy to explain here. So each component, so I have my pump 1, pump 2, a tank, and a reactor, and some lines. And the idea is that each component has some internal behavior. And this is called the finite state automaton. And if I take here this on the right side, you can see this is the example for a pump. And I say that it has 2 states. It can be either in the state working or in the state failed. when it's working, the outflow, so meaning what's going outside the pump, is equal to the same thing that is going inside the pump. This is the outflow is equal to inflow. However, if the pump is in a failed state, then there is no outflow, whatever the inflow is. Okay, and there are two events that can be triggered. There's the failure events and the repair events. And what you see below is the exact same code that is used. This is a language called Artarica. And Artarica is really object-oriented language, but really tailored for safety analysis. And so what we have below is exactly the same thing that we see in this little model here. So we have what they call a domain, and here the domain can be either working or failed, but we can put whatever we want, basically. Here we have the class pump, and we see that it is repairable state. It has the initial state working. We have the inflow and outflow, which is a Boolean, so it's either true or false. We have this event, failure and repair, and here we have the transition. So basically it says that if I have the event failure, I can trigger this event failure only if my state is working. And if I'm in the state working, then it will transition to the state failed. And then for the repair, this is the opposite thing. And then we have the assertion. So the outflow, if the state is working, then the outflow is equal to inflow. Otherwise, we just say that it's false. Okay, and this is the whole principle of MBSA. And then, of course, you can represent the whole system. And here is a very simple system, but you can basically do a much more complex thing. One last thing that I need to explain before I move on is that MBSA has something called observers. And observers are Boolean formulae referring to variables of the model that allow the computation of RAMs indicators, so basically a safety indicator. But to reformulate it, they are basically probes or sensors that we put in the system to monitor the system. I will show you in next slide how it looks like. But this is a very important concept in MBSA because we use this to check the system, to monitor the system, but there we really have big questions about this MBSA, which is what we should observe. Here it's quite simple because it's a simple system. So of course we can check what is the state of the pump, what is the state of the tank, and things like this. But for bigger system, this can be a bit more complex than that. And yes, observer is basically this. We just monitor a specific thing. And so in Artarica, it would look something like this. So in this case, we want to check the inflow of water in the tank. And so my observer will look something like this, that I have a switch and I say just in case the inflow of the water is high, then I return high. If the inflow of water is medium, then I return medium, and I just check this basically. And at any given event that is triggered in the whole model, the observation will be made again. Okay, so I'm sorry, it was a bit long, but I had to give you a little bit of context to really make sure that we're on the same page. Okay, and the whole idea, the whole thing is that we want to integrate STP and MBSA. Why? Because as I told you at the beginning, STPA is generating a lot of scenarios, so many of them. So now, for example, for the system I showed, just for this very simple system, I could generate at least 50 or 60 scenarios easily. And we don't know really how to process them because this is natural language. There is no criticity in them, so meaning that we don't know which one is more important than the other. It's really hard to process when we have thousands of scenarios like this. And on the other side, we have this MBSA, which is really good at checking the states of a system, but we are not sure how to what to check exactly. So the idea starts from there that basically there is some good synergy that these scenarios from the STPA could be used to provide the MBSA some ideas for the observer. And we want basically to translate one to the other. So on one side, I have the STPA scenarios, which are natural language, and I want to transform this into Artarica, basically, so which is this language that I showed you just before. And in this case, we would just put all the scenarios into the Artarica and then check the whole system automatically. I mean, check all the scenarios, sorry, automatically in this MBSA tool. So that's the idea, and basically we need some bridge in between, and that's where the ontology was made. So maybe I hope we can maybe start a discussion after this presentation. This is the model that I have, and I know it can be perfected. But here's the idea: on one side, on the top, on the bottom, sorry, I have the STPA with the loss scenario, and each loss scenario has a control action, feedback, context, some descriptive text, control process, controller, and so on. And on the other side, the MBSA, as I just showed you before, has state variables, event, odd connector, in connector, what we call the brick, and each of these has some value. Okay, so how does it work? This is kind of the methodology that we have, where we want to build the MBSA model. So what you see here is with Airbus Protect, they have their in-house tool to make the MBSA, and this is basically just a graphical interface for the Artarica that I showed you before. At the same time, we do the STPA, and the idea is that I want to extract all the components of the MBSA and make some vocabulary of it, and then do the same thing for the loss scenarios, and then make some mapping between them, and then I can get this observer. So how does it actually work? So for the MBSA model, I use the tool from Airbus Protect, Synfia Neo, and from this I can export directly in some Excel sheet all the components with all the values and everything I need. Then I just have some Python script to serialize it and make what you see on the right side here. And so, for example, I would have this component that has this name. It is an atomic brick instant, but it also has a state variable and it has some value. And this is what I extract at the end. This is this red thing, because I will explain why at the end, but for now I'm only using values. I don't use anything else. I still serialize it because I think there's some potential that we can do something about it. But for now, I'm really just using the value. And finally, I upload this to Termit, and I will show you after how it looks like. But I the exact same thing for the STPA. So in this case, I use STPA Masterlight, so I can export everything into the Excel. Then I have the same thing that I have some Python script to get this kind of scenarios that you see here on the right, where I have the text of the scenario, I have the control action, the control process, the context. Here there is not the feedback. I'm not sure why I realize this now, but yeah, basically you have everything. And same, I will put it after I put it on the Termit. So now I have everything on that is serialized. I have all the MBSA elements and also all the scenarios. And now I need to do a mapping between these two things. And this is how it looks like in the Termit. So you see on the left side that I have my vocabulary for the okay, in this case this was electrical system of a Cessna. So I have all the things here, and then the idea is that I would map everything, all the scenarios you can see on the right. So I have all the scenarios, and I assign the terms that I need to. So for example, for this scenario that I told you about before, the scenario 2.1, so I have the flight crew that is providing the set battery to use. And in this case, I have to kind of understand the system. This is also kind of issue that we have now, but I will come back to this a bit later. But in this case, the set battery to use, the equivalent in my MBSA system is fly crew battery relay output is nominal. So basically, I just send the output of the battery, and then I have to do this for everything. I have some pre-annotation. What you can see in the brown is because I pre-annotated all the scenarios with what is control action, what is the controller, to help a little bit the analyst to do this. And then I get this instantiation. So here I have the scenario 2.1, and here I get all my things. So the control action is this one, the context is this one, and then same for the MBSA. Now I have everything I need. Basically, the mapping is done. The scenario is mapped to the MBSA. And the last step is to turn these scenarios that are now mapped with the MBSA into observers. So like this thing that I showed you before, which is this kind of probe in the system. So now all this mapping is done. This is what it looks like at the end. And again, then I just have some script that will turn all this mapping into directly some observer. So in this case, this is what you see at the value here. So this scenario would be the flight crew output battery output is nominal, and the state of the battery is failed. So this represents the overheated state. So overheating basically means that the battery is not working. And the input of the flight crew, so meaning its feedback, is nominal, meaning that okay, so the output here of the flight crew, we say that it should work. We send the output for the battery, but the battery is not working, and the flight crew knows that the battery is not working. So this is our unsafe condition, and now we can put it directly into the MBSA. And the idea behind this is that we can check if the loss scenario can really be simulated. Does this scenario make sense to put it there? And then at the end, I get even some probabilities of the scenario to happen in the system. So this is the whole idea behind it, to really make the bridge between the STPA and the MBSA. So this is already almost the end. So just for some further work, because of course this is far from perfect. This is really something we are started, that we are still exploring. So I'm already pre-annotating the scenarios, but they are basically empty. This is just like some color for the analyst to know what he should annotate, but it would be great if the system by itself would know what to put into the scenarios. So I know Termit has some NLP capabilities, but I have no idea how to use this. I don't even know how it would be possible to do, and if it would be possible to do. Another way to do this would be to have it rule-based. So we already did some experiment where okay, it works in theory, like for some small system like toy system, it works, but in real life we talked about this with the guys from Airbus Protect, and this would be really hard to do this kind of things. Like at that scale, it would not really be viable. Another thing, there is a lot of research pointing this way, to plug it to LLMs. This is kind of trending. At this point, I really do not really recommend it. Why? Well, the LLMs basically are used to generate the loss scenarios, and most of the studies that are doing this are really just opening ChatGPT and putting some information and basic prompts and say to throw some scenarios. And okay, I'm not saying that it will never ever happen, like Miro presented last time. Like it's evolving very fast, but this is really not mature enough for me at this point, especially that there is not really any methodology. Like there is no, at least if there were some connection to the RAG, or just the question about how to explain the LLM what our system is really problematic. I have no idea how to tell the LLM. So at this point, I would not go much this way. And one big issue that we have also is that this whole pipeline is only working for failure-based scenarios. So meaning that if a component is failing or these kind of things, for everything that is organizational, if we have some software in our system, this is kind of hard to model. This is not impossible. So we are pretty sure that we can simulate it somehow, but yeah, this is still something that we need to investigate. And yeah, okay, that's it for me. Thank you. And if you have any questions, I'm happy to answer.
Okay, Max, thank you for the presentation. And are there any questions?
Maybe for me, a simple one to start the question session. I think it was on slide 20 when you were showing the termit. Yeah. So I'm not sure, how do you know that this scenario is, or you have it from somewhere else, but in the text it says does not provide, and how do you know that it is does not provide when it's not annotated, or you take it from somewhere else? Or that's not important?
It's not, I mean, okay, now it's really based on the judgment of the analyst. So now here I know that, for example, here I have provide, so I will put that it's nominal, so meaning it's working. If I would have does not provide, then I would say that it's failed, or at least not the equivalent. That would mean that the command is not sent.
Okay, so you don't have you map this not provide to fail and nominal.
Yes.
And I guess alteric primitives, or like how you do that?
Yes, yeah, exactly. Yeah,
okay.
Exactly. So this is kind of default primitives that are there. That's why we use this one. If the model is a bit more expanded, like we could have different values and put something that makes a bit more sense. It's just like in this use case, the model was made this way.
Okay, thanks.
Hey, Max.
Yeah. Go ahead, Martin.
Okay. Super interesting, Max. I'm just curious whether it would help you, because as I understand it, you have to do this annotation intermit manually, pretty much.
Yes.
If it would help you in STPA master, the full version, the text of the loss scenario is built from components. So if you did have these components, for example, the text of the scenario is built from this is the controller, this is the control action, this is the context, and this is some glue text between them. So if you could get the scenario in this kind of structured way, do you think it would be possible to define some mapping rules between the Authorica language and the parts, the structured parts in the scenario?
This is actually a little bit what I'm doing. So because it's kind of a long time I've been working on this, so I was still using the master light. But I did this kind of things where I know which one is control action. Like basically all this pre-annotation is because I have this data, but I cannot really do anything about it. It's like I was showing here that, okay, in theory, we could make some rule-based, but we are still thinking that for very big systems, it would be really hard to make this rule-based. Then it would be so hard, they would take more time to verify they make sense rather than do it directly manually. Or maybe there's something I'm missing and there would be some smarter way to do it.
Maybe I can contribute a little bit to this. I think for Max's hard part to, and what cannot be done really easy, is to extract the additional stuff, not just the controller and the control action, but the state that is described
Yes.
in the loss scenario, which is just full text. Like the battery is not connected. But
yeah, it's really based on the context, and you really it's really hard to extract what's the equivalent of this. So yeah, that's the problem I have.
Okay, well, in that case, I think these are the scenarios where the context is manually written, as I understand.
Yes.
Right?
Yes.
But you can also have, or actually the unsafe control actions, but the loss scenario context is based on the unsafe control action. You also have unsafe control actions that can be based on variable values, and in that case, you can just say, okay, this is the variable value, or this is the variable, this is its value, and that maps to something in Autarika. That could help automatically.
Yeah, this would help. Yes, for sure. Yeah. I think
Okay.
this would be a good hint. Yeah.
Yeah. So this is something that you can definitely experiment with in STPA master.
Yeah, I will definitely do this. It's true that because I was working on it, I was using the master light, so I kept going there. But now that the STPA master is ready, it would be probably useful to migrate there.
Yep. Yeah.
Okay, I didn't know. That's interesting. We can add variables to master, to the STPA master. Okay.
Yeah, you can even have rules that say, okay, this combination of values is hazardous. These are features that were added, I don't know, a couple of months ago. But yeah.
Do we have some? Do you know if we have something, some examples that are done from
definitely.
Slobodan?
Yeah, I don't know about Slobodan, but we definitely in the development instance we definitely have examples of that.
Okay.
You can ask Andrei because he created those values or the examples. So I think you can check with him.
Okay, thanks. Regarding this part, I once experimented with ChatGPT and loss scenarios from the STPA analysis from the STPA master, about STPA master. So this meta analysis of the of the tool itself. And I tried to make a prompt to extract exactly, like I asked the GPT to give me like a structured, like JSON response that will give me all the objects, their states, and the transitions, like event-like transitions between objects and their states. And I was quite surprised how good it was doing stuff. But I'm not sure for bigger text what it would do. But maybe if always prompted for one particular scenario, it could be checked and verified that it's done correctly. But again, there I guess if you have a lot of documents, maybe not just STPA, but maybe some documentation and stuff like that, then we always have this problem of aligning like the different sources because they might use different labels for different like components and stuff.
Yeah, exactly. I think it would be quite useful for the context. For everything else, I think it's too. I didn't have time to work on it, but where it would be useful would be. Okay, that I have these domains in the Artarika, so and I know basically all the values, the working fair, and for each component. And so we would, if Martin, you say that it's possible to do similar thing in the STPA, then I could align this basically, and this would help
Yeah.
already a lot. And then there would just be the context missing. The context, it would be pretty hard to do something, and this is where maybe the ChatGPT could help, at least to do some basic things and try to align.
Moreover, at the department, we have a group that is specializing for that to extract with LLM some JSONs, like.
Oh, okay.
So maybe it would be nice to contact them.
Yeah.
Yeah,
Okay,
but the problem with this approach always is that someone has to check it because it's it's not reproducible usually, and it can make mistakes, which is in this domain, I think, quite big handicap.
Yeah, I mean, of course, for all these kind of things, at the end, we always will ask someone to verify the scenario. So I guess he would to annotate everything automatically would speed up. But at the end, like at least in when we scale it, we would always need to have someone to check it anyways.
So basically, you are the ChatGPT for somebody else.
Yes, exactly.
Yeah, and you said that you would not like to use LLMs for generating scenarios, right? That's what you said.
It's not that I wouldn't like. It's just that the current way it's done now, when I see the literature, it's like the methodology is really bad. It's basically just people opening ChatGPT and putting and asking, okay, generate me some scenarios.
I would not. Yeah. Go ahead.
That's right. Yeah, no, I just to say, yeah, maybe there are some better ways to do it. So yeah, maybe if we have some, at least some RAG and yeah, for me, the biggest issue is how to describe the LLM, the system. Like for me, it's really big issue. How do I make sure the LLM really understands my system?
Mm-hmm. Well, so maybe not for generating, but how about validation to some sense, to find that if something is missing, or to really like only check what you already created instead of letting it generate. Yeah,
this could be an application. Yes.
It's funny because in my experience, generating the scenarios is the easy part because we are able to do that completely deterministically from the unsafe control action. So the scenarios are, in my experience, the easy part, and there is no more LLM in that regard.
No, I mean to check some kind of completeness or stuff like that. Not completeness from what is generated, but checking whether there is something missing that would lead to generation of scenarios. Yeah, that's what I mean. So understanding the context of how the structure is modeled and what could be missing there. So giving some hint to user that this part is underspecified or something like that.
Yeah, I mean, this is a good way in the sense that STPA is quite new, and most of the people that are actually doing it are making a lot of mistakes because they don't have really a lot of experience. So having some system that is telling you that something is missing could be useful. But I guess this is already what the STPA master is doing, because it's guiding you for the scenarios and all this. So I'm not sure. But for someone that he's doing it manually, this could be for sure some good help.
Okay, so thank you all for the comments.
Maybe
are there any more? Yeah, okay.
Just, I don't know how I can be to actually give some actual correct terminology about this, but there is this thing, I think it's called model checking. and essentially you do something similar as you do in STPA or MBSA, Alterica. You create a model, and then you have you check it, and the checking is done similar. You can say similar as you do like validating ontologies for logical consistency. So it's based on logic rules. But the thing is that it doesn't like give you it doesn't check everything with trying to be smart about the axioms that you put in the model and trying to verify generally that this is correct, but it does it by example. So it generates lots of examples, and you tell him how many examples to generate, and then it checks if it follows the rules that you ask it to follow. So so it's logic based, but the thing is that it generates lots and lots and lots of examples, at least as much as you give him, and it verifies the constraints, let's say. So I've seen this, like if you remember UFO, so there is a tool, it was, I don't know if it's still there, where they, to build UFO ontology and with the original intent, so it's formal. And so you build the ontology, then you can check, verify it. And it was working like that you generate using this kind of model, checking different instances of that ontology. And you can look at it and verify if it's correct or not. So what I'm trying to say is that if you have a model of all the variables and states, then theoretically, and maybe how they relate to each other, maybe theoretically you can use a model checking some kind of a engine that will generate lots of scenarios essentially for you.
Okay, that would be great. Yeah, if you can send me later some link to this, some resources, I would check.
Yeah, unfortunately you have to build the model. That's the
yeah.
And it's another formal language similar to the Alterica one, I think.
Okay, but at least I could try it on some simple things just to see how it works and if it's worth it to continue. Yeah, thanks.